In Chapter 9, we've learned a lot of pieces and parts and definitions, and we have four different kinds of confidence intervals that can get really confusing. So we're going to take a page here and just kind of regroup and figure out what we're talking about. Okay, so in section 9.1, we were dealing with the parameter P, which stands for population proportion. Right? Very important for the sake of surveys, polls, that kind of thing. Right. Now, that's the population value, the parameter. The statistic for it is p hat, which is the sample proportion. All right. Now, don't forget there's a formula for p hat, always helpful to have everywhere you can write it, just so you never forget it, which is x over n. Right? There's the sample proportion. Now, the formula for that is right here. But remember, you don't have to memorize this formula because that formula is right on your inferential statistics sheet. There, I pulled that up right here. So it's the one sample proportion, so that's p hat plus or minus z alpha over 2, big square root of p hat times 1 minus p hat over n. And you can see right on the inferential statistics packet, I'm telling you what calculator entry you'd use, which is letter A, it's 1 prop z int. All right. Now, what distribution is being used? We can tell from inside there, you can see that it's a z value. So since it's a z value, that means that you're using the z distribution, funnily enough. And then the critical values, therefore, would be critical z values. And they're right in the formula. They're the plus or minus z alpha over 2 part. All right, just a little quick refresher of how to find that. So you go to stat, go to tests. To find the interval, you'd go to letter A, so second, or alpha A, excuse me. And here's one. I had 40 and 100.95, enter. And there you go. You have your interval, there's your p hat, there's your n. Remember that p hat is the center of the interval. That's your point estimate, right? So that statistic up here, that's the same thing as calling it point estimate. Right? So when we ask for the point estimate, these guys right here are what we're looking for. Matter of fact, I'll even highlight them for you. All right, now what about section 9.2? Well, 9.2 was looking at the mu, which is the population mean. And the statistic for that, which is also the point estimate, would be x bar, which we've known for quite some time. That's your sample mean. All right, population mean, sample mean. This is the point estimate. This is the value you don't know because it's for a whole population, and whoever gets to know a whole population, really. All right, now the formula for that is x bar plus or minus t alpha over 2 s over the square root of n. And again, you don't have to memorize it. It's right here. It's in the top right corner. And right here, I tell you which one to look for. You're going to look for t interval. All right, t interval is, I believe, number 8 on everybody's calculators. I don't want to say for certain because some calculators might be different, but for the 84s, it's number 8. So that's the t interval. I can't remember if it's capital T or lowercase t. Stat, tests, t interval, capital T. There it is, 8. All right, now when you choose t interval, you have a choice when you're running it on the calculator. You either have the option of data or stats. Now remember, data, if you press enter on data, means you have some data set in list 1 that you want to look at. So you put in your data set for list 1, always leave your frequency list at, your frequency at 1, put in your sea level, and then calculate fine. Now, if you don't actually have a column of data, if no data was given to you, then they must have given you enough information to use stats. Stats is the one that you use if they give you a big paragraph with lots of words in it, but no data table. So there's stats, and you would type in values like, 350 and 100 and so on, and then put in your confidence level and then calculate. And when you do that, it'll tell you what x bar was, what s was, what n was. Of course, we knew those 3 in order to use stats in the first place, but if you were using data, let me see if I have any data in here. Oh, beautiful, I do. So stat, t interval, and I choose data, and then I go to confidence level and all that, and I go down to calculate, it'll tell me what X bar and S were for my data set right there, without even having to bother with one variable stat. All right, so now what distribution are we using to make this interval? Well, when you look inside the formula, you can see right there, it's the t distribution. So we're using the t distribution. Simple as that. All right, now if we're using the t distribution, what are the critical values then? Well, that's that plus or minus t alpha over 2 part of that formula. Those would be your critical values. Oh, and we better put in how we find these. So you find critical values with either inverse norm for z ones. So for z, you use inverse norm, area left, comma 0, comma 1. I should say left area. That way you can not get confused. Or the bottom row of the t table has some quick references. So if you use inverse norm, that's fine. That will always work. Bottom row of the t table has some of them, right? Not all of them. But if I use the t table at the very bottom, there's about, 15, or no, not 15, 12 of them here. So you could use those 12. But if it's anything other than those 12, you're going to have to use inverse norm. All right, now the t alpha over 2, you can find with inverse t, left area, again, comma degrees of freedom, right? df is your degrees of freedom, and remember degrees of freedom is n minus 1. Or the t table, right? Don't forget that degrees of freedom is n minus 1. Always helpful to know. Okay, so you can find that with either inverse t, so let me show you. So inverse norm was number 3. See, 0.05, 0, and 1. Paste, enter. There you go. Inverse t is number 4 in that list. 0.05, degrees of freedom is 10. Paste, enter. And there we go. And that's the same value, 1.812, that I could get from the table. If I had 0.05 and degrees of freedom was 10, see there it is, 1.812. The problem with the table is it's actually really handy to use, but it doesn't have every degrees of freedom possible. It only has all the degrees of freedom up to 40, and then it starts hopping, right? So you're better off with the calculator if it's a degrees of freedom that the table doesn't do. All right, so there's how to find those. Now we need the last one, which is section 9.3. Now 9.3 had actually 2 parameters at once. We had sigma and we had sigma squared. There, and I couldn't write all of it because population standard deviation is such a big, long phrase, but that's what it is. Population standard deviation is sigma. Population variance is sigma squared. So then S would be, well, an S squared. So S squared, which is sample variance. And then S is your sample standard deviation, which we've known about for quite some time. And there we have it. Sample variance, sample standard deviation. All right, now remember, these are linked, right? So the variance one goes with the variance one, standard deviation goes with standard deviation. But nevertheless, they're the point estimates, respectively. Okay, so then what are the intervals? Well, there's 2 of them. One is for sigma and one is for sigma squared. The top one is for sigma squared because it doesn't have the square root in it, and the bottom one is for sigma. You don't have to worry about memorizing it because it's right on your inferential statistics sheet, and I even tell you which one's which. The one without the square root is for sigma squared, the one with the square root is for sigma. Now this is one that your calculator will not do, so calculator not available, sorry. You'll have to do it by hand. I mean, you'll use your calculator to do the multiplication and division, but you're not going to use your calculator to be able to find this interval the way you could with these 2, because these 2 were actually standard loaded into the calculator. All right, now the distribution you'll be using is the chi-square distribution, right? That's what that variable is. It looks like an x, but it's actually not. It's a chi, the Greek letter. Okay, so the critical values, they're a little bit different. So you have the critical value of chi squared alpha over 2 and the critical value of chi squared 1 minus alpha over 2. Here, that looks a little like it's all 1, but it isn't. There we go. Now, where do you find those? Well, you find them from the chi-square table. So I'm going to go grab the table so you can see. And remember that you have two values. One will be on the right, one will be on the left. Your degrees of freedom is n minus 1. So chi-square table, your degrees of freedom is still n minus 1, just like it was for a t distribution. But you don't have the calculator options on this one the way you do for t and z's. T and z you could find with a calculator. You don't need the t-table. The t-table is just a quick reference sheet. But for the chi-square table, you must use the calculator, or excuse me, must use a table. You do not have the calculator available to you. Computers can do it, but you won't have a computer on you. All right, I hope that helps recap everything that we've done, and I'll see you back here for more videos in Chapter 10.